Good morning, everyone. Today we are going to start our new topic, which is going to be volume and surface area. So today what we are going to do is we are going to be reviewing volume and surface area of cylinders. And there you have it, volume and surface area of cylinders. Couple quick things. Number one, I don't know if you noticed that I've stepped up my video game, so I'm feeling pretty good about that right now. And then the second thing you should have noticed is that I have a calculator here. That is because I'm going to allow you to use a calculator. So I hope you're excited about that. Realistically, I know since you've been working at home, you're using a calculator anyways. But you now have my full permission to use a calculator, so that is pretty exciting. Well, at least I think it is. So I want to remind you, whenever we are working with formulas, we always put the formula, substitution, simplify, and answer. And that's the way it goes. So here we go. The formula for volume. So volume would be volume equals big B times H. Big B is something that was introduced in course 1, so you should remember that. Big B is the area of the base. So if I have something like this is a cylinder here. It's pretty decent artwork. My base here would be this, and this would be my big B. Now, hopefully you notice that this big B represents a circle. So my big B here would be pi r squared, and therefore, if we substitute that back in, the overall volume would be volume equals pi r squared times h, h being the height of the cylinder. So it's pretty straightforward as long as you can identify the radius of the circle, that is your base, and the height, you just have to put some numbers in a calculator. So here we go. This is example 1. I have a cylinder. I'm sure you guys miss my artwork. That looks like this. This radius is 3 inches. It goes like this. I have to say, I'm pretty impressed. I know you guys aren't, but I am. And this is 1.8 inches. So here we go. I have volume equals big B times H. Volume equals the big B, which is pi. My radius is 3 squared times my height, which is 1.8. So my volume equals, this is pi times 9 times 1.8. And I'm going to have you use 3.14 for pi. So on the calculator, I'm going to do 3.14 times 9. That there is going to give me my volume of 28.26 times 1.8. So times 1.8 equals 50.868. And then the directions will give you something like round to the nearest tenth or the nearest hundredth. So if I was rounding this, my volume here would equal 50.9. And then remember, we always have to label, so this should be inches cubed because we take the measurement and it's cubed. So that is the first problem. Sorry that my camera's moving around so much. I thought I upped my camera game, but maybe not. So let's do another example here of this. This would be example 2. I have the diameter, which is 12 millimeters, and I have a height, which is 5 millimeters. So the first thing I need to notice, I don't know if you can hear my family screaming in the background, but they are. So the first thing I noticed here is that I have a diameter and I need a radius. So remember, the diameter is double the radius. So I would take my diameter and divide it by 2, which would mean my radius here was 6 millimeters. So I have volume equals, this is pi r squared times h. Volume equals pi, my r is 6 squared times my height of 5. My volume here equals pi times 36 times 5. So over here I'm going to do 3.14 times 36 equals times 5. So my volume here is going to end up being 565.2. And there you have it. So there we are for volume. I don't really think we have, well, I'll do one other quick problem with you all to make sure that you have a good understanding. Again, I'm not sure if you can hear the meltdown in the background, but there certainly is one. So this is going to be from page 591. I'm just going to go ahead and fold the page here so I can show you my work. Okay. So this says the Roberts family uses a container shaped like a cylinder to recycle aluminum cans. The height, so we know that we have a height of 4 feet and a diameter of 1.5 feet. The container is full. How much do the contents weigh if the average weight of aluminum cans is 37 ounces per cubic foot? So 37 ounces. So here we go. First things first, I have 1.5 as my diameter, so I need to divide it. My radius should equal 75 hundredths. So here I have pi r squared, volume equals pi r squared times height. Volume equals pi 0.75 squared. I'm giggling because my children are screaming in the hallway right now while I'm trying to do this. And it's hard to concentrate on anything other than the meltdown that is happening over kindergarten writing. So I'm sure you guys can relate to that. I have 3.14 times 0.75. Oh, I'm sorry. I need to start by squaring it. So 0.75 squared is going to give me the volume is equal to pi 0.5625 times 4. So now I'm going to multiply that by 3.14, and then I'm going to multiply that by 4. And so my volume here should be 7.065. Now, that is the volume of the container. I now need to take that container and multiply it by the 37 ounces that each can weighs. So I'm going to take that and multiply it by 37. That then gives me that the entire filled container is 261.4 ounces. That is the weight of the container. So there you have it. I hope this helps. If you have any questions, let me know, and I will talk to you all soon.